Hey everybody, it is John Shutsky with BSE 508, and we're going to talk today about evaluating different design alternatives. And we're really going to teach today, I guess, a process for selecting things from among many different types of alternatives. And I'll give you some examples here. What might you have to select in your life? Now, at the very beginning of this class, at the beginning of this semester, you had to select from among different projects. So you were probably looking at a lot of different factors. We were looking at a lot of factors, and that included your emphasis area. We were interested in what your numerical score was. We also wanted to balance off our team so that we had a mixture of people from different parts of the program. Also, we had wanted people who were representing different genders on the different teams and those kinds of things. So that would be an example. You might also have a situation where you are comparing and trying to make a choice from among different alternatives. Maybe you've got competing job offers, or maybe you're contemplating a couple of different internships. Or it might be that you've got really great job offers from the same company, but you're looking at different parts of the country that you want to live in. Do you want to live in the southern part of the US and have it be warmer? Do you want to live in the Midwest? Do you want to go out to the West Coast? Things like that. So these are skills. This is a technique or a series of techniques that really are applicable regardless of the types of choices that you make. Obviously, here in this class, when we get towards the end of the semester and we move into the next semester where you're going to begin to put your designs onto paper and then ultimately begin to build and test prototypes, you're going to have to choose from among different types of design approaches, if you will. And these are also the same types of approaches that you'll need to consider when you do homework number 8. So this is a real key part of that homework 8. First of all, beginning to put those different design approaches onto paper. The other thing is, once you select a design approach, you may have to actually go in and look at subsystems or components. Maybe it's a part of the machine or the wetland that you're designing. Maybe it's choosing from among different types of plantings or biological aspects to help supplement the actual physical design of your wetland. So lots of different things that need to be considered and lots of different choices and decisions that need to be made. Here's just an example. This is actually a project that came to us this semester, and we didn't include it in our portfolio of projects, but many of you are probably aware that walnuts like these walnuts here from Costco, about a $12 jar or plastic container of walnuts. These walnuts grow on trees. And when you harvest the walnuts, either by hand or typically harvested with some type of a machine, they come off of the tree and they're surrounded by a fairly thick and tough, called a rind. It's kind of like an orange rind or an orange peel, a little bit tougher than that. That walnut rind is actually, it has some chemicals in it. It's kind of really dark and almost like an inky brown, it stains things very, very dramatically. So we've got to get that rind off of the walnut. And then also, to harvest the actual nut part of the walnut, you have to crack a really hard shell. Some of you may have had a walnut or a nutcracker, and you've done this with walnuts and pecans and other types of nuts. So the project that came to us was about how to get off both the rind as well as that hard outer shell, the brown shell that you see in the lower picture. So let's just assume that we had gone through the process in this class of doing the literature review, looking at patents and standards and the ways that this type of design or this type of job had been accomplished in the past. And maybe we came up with some different alternatives. And the alternatives, this one's a little bit complicated because with a task like this, you've got to both peel off that green outer layer or that rind or husk, but then you also have to go in and crack the nut and extract the actual meat or the actual nut itself. So let's just say that as a result of all this work, you came up with these 4 alternatives. First of all, mechanically tumbling the nut to abrade or to kind of wear off that outer shell, and then crushing the actual shell of the walnut with some type of a machine like a hammer mill. or running it through a series of rollers to actually crush or crack, or maybe like a series of jaws that were like a set of pliers, like a giant nutcracker. Another alternative might have been that we're going to use a chemical, some type of a chemical peeling agent to peel off that outer layer and create just where we just have the raw brown shell, and then use a mechanical crushing technique for that. Or maybe a third alternative is we're going to dissolve off that rind with chemicals, but then we're going to expose that outer shell. We're going to dry it out a little bit, but then we're going to expose it to a really short burst of high heat, enough heat to rapidly expand that outer shell and crack the nut. Another example might have been that we're going to use some type of high pressure water jet to kind of scrub off that outer rind like a high pressure power washer. And then again, now we've just got the brown shell, and we're going to use mechanical force to crack the shell. So these might have been like 4 alternatives. This one's a little bit complicated because you might want to actually do separate decision processes for each one of these, for both the getting off the rind but also cracking the nut itself. But in this particular case, if a student group was working on this particular issue, they would want to look at both processes, and they would want to go through some type of a decision-making process to make sure that they're optimizing the resources and fulfilling the project design specifications that they've laid out for this project. So question number 1, and again, I'm going to ask you to go on to Canvas and fill out the participation assessment for how we do, or how we consider different selection alternatives. What I would like for you to do at question number 1 is to outline 4 design alternatives or approaches for your project here in BSE 508. Now, what's really good about this is you do this assignment, or you do this little couple points you're going to get for doing this and for watching this lecture. You're also going to have some usable information, so you might want to copy this into another file someplace, because you can also use these same 4 design alternatives for homework number 8. Homework number 8 is about safety, but one of the things that we ask you to do in the safety-related assignment is to look at the safety issues connected to 4 different alternative design approaches. So I'm going to give you just a minute to do that, and then come on back. So in this lecture, we're going to talk about 4 methods, or 4 categories of, there are 4 methods for selecting from among different design approaches. And these are, number 1, voting. Number 2 is also voting, but instead of one person having 1 vote, we give each person multiple votes. I'll explain these in a minute. Another one is something called a screening matrix, and yet another one is a specification times concept times a scoring matrix, also referred to as the Pugh method, P-U-G-H. Not like Pew the smell, but Pugh. It was Dr. Pugh, who was a design engineer who taught senior design back probably about 40 or 50 years ago, and his method is still used commonly by engineers. What I would like for you to think about this is when you go through the process of selecting from different design alternatives, is to think of it as a learning tool, or a tool to help you to further develop, refine, combine ideas, and innovate. It's not about which concept or approach or part or person wins. This is not a contest. You may wish to iterate over and over and over again and actually arrive at a more unique or novel solution. To evaluate these approaches that we're talking about, whether it's concepts, components, parts, subsystems, etc., it does require really good information. You do have to do your homework, and that includes also having your drawings, your models, your specifications, and the different types of data. Because if you're going to be evaluating concepts based on data, you've got to have good data, which means you have to have done your homework. It's also really important, if you're working with a team, including the team that's working together here in this class, is that you not insulate yourself, that you're making sure that you're talking to other people. In this class, that includes your advisor. It includes your customers or your clients. It also includes continuously collecting the type of information that will help you to help eventually lead you to a good decision. Another way to look at this is that you will, hopefully you will develop a series of concepts, alternative design concepts, which fulfill at least some of your project design specifications. You will begin to screen those on the basis of your project design specifications and the data that's connected to each one of these design alternatives. You'll score these using some type of method, and eventually you will make some selections. You'll head down the road of actually beginning to put pencil to paper to actually put your design in a CAD model or other type of format. You might actually go back to those original concepts and maybe borrow an idea that you had early on. So again, this is one of the reasons why we ask you to keep a design notebook, because you want to go back as you filter down through that funnel. You may need to go from the blue stage, the blue dots that are represented in this funnel or this tunnel, and you may need to say like, hey, let's go back to one of those red ideas that we initially had and borrow something from that and bring it forward as we begin to refine our solution. So again, I'm going to go through these four. The first one obviously here is voting. And the first one we often think about, we've got 5 people on a team. Who votes for which design? You got 5 design alternatives. Who wants to cast a vote for alternative number 1? Simple voting might be okay if you are making a really simple decision. However, it is really tough if you have multiple alternatives. If you have 2 candidates at the end of a presidential primary voting for one or the other, that's not all that difficult. If you've got 5, or in the case of our recent presidential election where you had the Democratic primary, at one point you had 20 different candidates. If you are spreading votes across 20 different people, it becomes really, really difficult. Let's just say, as an example, to show you the complexity, let's just say that next summer, this would be the summer of 2020, we have the International Conference of the American Society of Agricultural Biological Engineers, ASABE. Some of you may be planning to go to that conference, and for those of you who do go, you're going to meet students from all over the country, probably actually all over the world. And let's say that you've got a group of students, undergrads, that get together. You've got 12 from Cornell and University of Florida and Cal, Davis, and you've got people here from UW-Madison. You got 12 people. You do a quick count. You find, okay, does anybody have any special needs? We're all going to go out to eat. Does anybody have any special needs? And you, right away, that of the 12 people you've got 6 people, half of the group are vegetarians. Now, if somebody comes to the group and you've done some homework and you've got a list of potential restaurants to eat, so you've got Bill's Steak and Chop House, so people are really excited about that. You've got Cafe Namaste, which is an Indian restaurant that's got a full menu. It includes some vegetarian selections. Some people are super fired up about a restaurant that they heard about called Roots and Shoots. It's strictly vegan and a little bit of vegetarian. And then last but not least, you've got, it looks like more of a bistro. It's called Real Food Daily, and it has a full menu. And there's also some good vegan and vegetarian options. So you've got 12 people. Have a look at what happens if you've got, in this case, 4 different alternative restaurants and you give everybody a single vote. How do you make the choice? Like in this particular case, the biggest vote winner was Bill's Steak and Chop House. You had 4 people. You had 1/3 of your voting population of 12 that voted for Bill's Steak and Chop House. If you're a vegan or vegetarian, that might not be a really attractive alternative. You've got a tie between Cafe Namaste and Roots and Shoots, and so that's kind of a problem. How do you deal with these kinds of issues? So single voting, or having a single vote per person, really does have some limitations unless you have narrowed things down to just perhaps like 2 different design alternatives. There would be a whole bunch of other things that you need to know, right? So you might need to know, these are like your design criteria. Like, well, what about the cost? If I'm going to go back on this selection and I'm going to vote, I need to have a little bit more information, right? Like, I want to know, I'm on a budget. I'm an undergraduate student. I don't have a ton of money. So I need to know, what's the cost? I need to also know, how far away is this from the hotel? When I get to it, if we're going to walk there, is it in a safe neighborhood, just as an example? What might the waiting time be? There's another meeting I want to try to go to at 8:30 in the evening, another student group who's getting together. And if this is something where we're going to be gone from our hotel for 3 or 4 hours because there's an hour and a half waiting. I want to know that. What are some of the other menu items? Are there other attractions nearby? What about the typical clientele? Are we going to stick out as college students? Is this going to kind of fit our vibe as we go out and eat our meal with a group of people from around the country? Another possible approach is to, when you've got multiple things from which you're trying to make a decision, is to give every person multiple votes. And we often see this happening in business conferences where you've got, maybe there's 5 or 6 or 7 different concepts, and you're going to tell everybody, we're going to give you 5 dots, 5 sticky dots, and we've got posters around the room that kind of spell out our different concepts. And we're going to ask each person to place their 5 dots, and there may be ground rules. Often the ground rules look something like, you can't place more than 2 or maybe 3 dots on any one concept. The idea here is to try to spread the weighting around a little bit so that you can get some diversity of thought and perspective. So you might look at this and okay, you do a count. Well, concept number 3's got the highest number of votes. But then I look at this as well and I say, okay, concept number 1 has a pretty big number. And also concept number 7, there's a few there that we really need to talk about and consider. Concept 5, yeah, not so much. Concept 6 has only got 2 votes. So what might you do in this situation? Well, what I've seen happen very successfully is that perhaps you take concept number 1, upper left-hand corner, concept number 3, upper right-hand corner, and concept number 7 in the lower right-hand corner, and you have a little bit of discussion. You let people express, why was it that you put, you might have put 2 or 3 of your dots on those particular 1, 3, or 7. Talk a little bit about that. Well, what about those concepts were the most attractive to you? You might find out that there's some things in concept number 1 that people maybe didn't quite understand, and yet there's some really cool parts of concept number 1 that you don't want to lose. So maybe you can take some of the components of concept number 1 and bring them over and kind of merge them into concept number 3. And so that way you're kind of combining. You got a lot of power there. It's beginning to develop a coalition of votes. I wouldn't, if you did it this way, I also would not neglect concept number 5 and concept number 6. You've only got 1 vote in number 5 and 2 votes in number 6. But it may well be that one person said, there was this one element of concept number 5, or there was this one piece of concept number 6 that I really, really liked. And it may be possible to peel off that notion or that idea or that concept or that nugget of information and merge it into maybe number 1 or number 3 and really make those even stronger. So this is a method that I've seen work really well when businesses or organizations need to make some really difficult decisions. It's a way to generate conversation, to learn about the options and the alternatives. And it is a way to begin to generate some of that discussion, which in the end can lead to some really positive results. Here's a method that many of you have probably used before. It's called the decision design matrix. And you can, again, apply this in lots of different ways of thinking about making choices in your life. So let's just say, for the sake of argument, here we are, we're approaching the end of the spring semester. Some of you are planning to live close to campus, but not super close. You're going to live about 5 or 6 miles away. You've got a reasonably cheap summer sublease on an apartment, and you've got to make a choice on how you are going to get to and from that work that you've got here on campus. So you might want to sit down, and again, these would be equivalent to your project design specifications, or in this case, your objectives. Your objectives are, I want to have a relatively low travel time, low cost, high comfort level. I want to be able to come and go. I don't want to be dependent necessarily on a really fixed, rigid schedule. I want this transportation to be reliable so that I can't miss work. So I want to make sure that I'm there every day. I want it to be safe. I also want, some people really like when they're doing transportation. Some people I've heard like riding on a bus or riding on a train because they can do other things. They can multitask. Some people multitask when they're driving in a car, you know, they listen to podcasts and things like that. But maybe you've got the desire to be productive. Maybe you're also one of these people who says, like, however it is that I get to work, I want it to do something that'll be positive for my health. Or that I want things to be private. I don't like riding in a crowded vehicle with other people. Or maybe you're saying, like, a big part of my criteria is I want this to be environmentally sustainable. The other thing that you might want to think about is when you talk about project design specifications, or in this case, the objectives that you're trying to meet through choosing a means of transportation, they probably are not all weighted equally. Like for me, travel time's like a really big deal. Travel time, I would love to have a mode of transportation that I could consider to be environmentally sustainable or that would actually improve my health. I actually have to drive about 25 minutes every day to and from work. Um, but it's not as important as travel time. So I'm probably going to want to weight these. And in this particular case, you can see we weighted things from a high of 10 to a low of 1. I've also seen people develop rating schemes where you together as a team, you decide together how things should be weighted. And maybe you start with a total sum of 30. And then you have to spread those 30 points out among your, in this case, we have 1, 2, 3, 4, 5, 6, 7. We have 10 criteria. So you're going to want to spread those criteria out and make sure that you have a distribution in your weighting system. Or it could be you're going to have a sum of 30 and they're all equally weighted. And so you're going to give them all a weighting level of 3. But in most cases, you have some factors that are more important than the others. Okay, now you've got you have your different types of design alternatives, or in this case, your transportation alternatives. You got bus, a scooter, or a moped. You could own a car. You could maybe share a car with other people or carpool. You might have a bicycle, or you might actually choose to walk or run. And again, you would be ranking these on the basis of the objectives and then weighting them. So this would be just the raw rating. So I don't need to go through this. Bus, probably not the best, a little bit longer travel time. It's not quite a 0 or a 1, so I'm going to give it a 2. It's going to be cheap. I don't have to worry about car ownership. All I got to do is get my hands on a bus pass. If you're a student, you may get either a free or a really low price bus pass. Comfort level. So again, in this case, a 5 is like really positive. So car, like really low travel time relative to the other ones. And so forth. So 5 is high, it's a positive, and a 0 or a 1 would be on the lower side. But again, what's really important to remember is not all of the objectives have the same weight. So you need to multiply the weighting times the score. So in the case of bus, it's a 20, and that's a 10, the weighting of 10 for timeliness multiplied by my rating, which must have been a 2. And so you've got this matrix now that is a weighted decision design matrix, and you can add up each column to begin to narrow down your choices. You know, in this case, bike, pretty much head and shoulders above everything else. Car, not too far behind, and then walking is actually also not very far behind. But one of the things that is also important is to look at where your really low scores are. So in the case of biking, productive, not very high. Safety, there's some safety issues there. It's got a 6. Comfort level, on a really rainy day when you've got thunder and lightning and wind, not particularly comfortable. So in some cases, you may end up kind of combining a couple of approaches. So maybe your combination is some of the days when it's really beautiful and sunny and nice out, I'm going to bike. And on the rest of the days, I'm going to need a car. I'm going to need some type of backup. I don't necessarily want to be dependent on a carpool because you can see that had a really low score. But you get the point. Like, again, the idea here is to use this as kind of a guide, a way of looking at where those high scores are and maybe taking the best of the best, recombining some ideas, and maybe from a decision design matrix that's weighted like this, you end up coming up with an alternative that really combines a couple of these high rated scores that wasn't even on your matrix in the first place, and you've got an entirely new concept. So again, use this as a guide. It's not which one wins that you end up choosing and building, but use it as a tool to ensure that you're really fully considering the alternatives in a thoughtful, thorough way, and that you're also using it as a potential tool for creativity. I've talked about some of my past design work back in the mid 2000s, probably around 2005. We developed a fully automatic sensor system that would detect people who would be walking, say from the bottom of the screen where you've got 90 or 130 or 140, walking at a relatively high rate of speed into a potentially dangerous location. In this particular example, the area or the zone of protection between the back end of a tractor and a self-unloading forage wagon, where you've got rotating power takeoff shafts and you've got lots of moving parts, a potentially very dangerous area. So we developed a sensor system. We actually, we won an award for the paper that we wrote as a result of this. Again, it was a peer-reviewed journal article. I had a couple of students who worked with me. We developed apps and data acquisition systems, and then we had control systems that both provided a visual, an audible, so you could see things, you could hear things like an alarm system, and then also if the person got close enough to the hazard, we would actually shut the machine down. So you can see that in this particular case, when we had to make choices about which of the sensing technologies we were going to build in to this design. So that's just one component, was which type of sensor did we want to use. So we did a ton of background research, and we developed project or product design specifications that included, on the left-hand column, we needed things that were dust-proof, dust-resistant, and also would be reliable when there was dust present. We needed a fairly wide range of temperatures. We needed to be able to deal with really all kinds of environmental extremes: humidity, noise, vibration, wetness. There's a good chance that this machine would be used out in wet, rainy, or snowy conditions. We also wanted to be able to account for variations in lighting, including sunlights, cloudy days versus sunny days, perhaps having shadows, clouds that would pass between the sun and where, the ground and where things were happening. And then also we needed to be able to account for background motion. If there were activities happening in the background, if you had a dog walking by or some other type of movement, some, blowing, leaves or things like that, we wanted to make sure that we were only detecting people. And so we did a huge literature review. Each one of these references shows a reference to a particular article. And in our decision design matrix, you can see down at the bottom, we ranked things on the basis of 0 was, yeah, we probably, based on the research that we did, probably cannot be used in that situation. Number 2 is like, yeah, this one's really good, this is a real positive. And number 1 was like, may work in some cases, but we may have some limitations or some difficulties. And so what we ended up doing in this particular case with this matrix gave us a huge amount of information, and it helped us to make this really complicated decision. In this particular case, it wasn't the highest scoring technology that was necessarily the best, because we might have had something that scored really high, but maybe in some conditions, like rainy conditions or with background motion, like it's just not going to work at all. The 0 suggested that it's not going to work at all. So what we decided to do is we decided to use combinations of sensing technologies. I think in the end, we ended up using the combination of radar. So we have the Doppler effect of a sensor seeing an approaching person and their velocity based on the Doppler shift, but then we also used infrared, so that we could detect the person's heat signature, their infrared body temperature. That would also help us distinguish between a tree blowing in the wind, and a person who actually emits infrared heat energy. And so this was like, this particular design matrix was just so valuable to help us make a smart decision. Here is the I guess the fourth method, the idea of controlled convergence. Um, I have mixed feelings about this. I've used this and I've seen student design teams use this successfully. This is, remember earlier I talked about the Pugh method, P-U-G-H, named after Professor Pugh. So what you do with the Pugh method is essentially you do the same thing. You have your objectives, your project or product design specifications, you have weighting. In this case, we weighted things either 3, 2, or 1. So 3 high priority, 1 lower priority. And what you do with this particular design matrix is you choose one of the alternatives. Usually you pick the one that seems to be like it's going to be the most obvious winner. That's not always obvious, but you pick one, you just need a starting point. And in this particular case, we're going to choose the car as our starting point. So you're going to own, or you're going to have a leased vehicle, you're going to have your own car versus biking or walking or taking a moped or a scooter or carpooling or etc. So that we're going to call that datum. And I don't like the term datum. This is what Professor Pugh used, but it's kind of it's your baseline, right? So your datum is your baseline, and you are going to compare all of your other criteria as either being better than the baseline or worse than the base. So it's either going to be a plus, is better than the baseline, worse than is going to be a negative. So it's a +1 or -1, or if it's the same, if it's like essentially the same, you could rate it as a 0. And you're going to compare that to your baseline or to your datum, I should say. And so in this particular case, we've got travel time. We've got cars, the datum. So bus, like, yeah, no, clearly if I'm going to be on a bus schedule, instead of being able to make it to work in 12 to 15 minutes, it's going to take me 40. So that's probably going to be a negative. Scooter, well, if with the scooter, depending on the route you take, it may be about the same as a car, maybe just a little bit longer, but essentially the same as a car. Um, Carpool, well, it depends. If you've got to go pick up 5 people on the way to work, it's probably not going to be as fast. If travel time is an issue, it's probably not going to be as fast. Bike can be a little bit slower. Walking is obviously going to be a lot slower. So all of those are going to be negatives. And you do that for all of the criteria, comparing each one of your design alternatives. You weight it and you compare it to the datum to start out with. And then again, you sum the various columns. Okay, so in this case, there are actually, and we look at this and it's like, okay, datum 0, it's 0 as a baseline to start with. There's nothing that's +1, but we also have walking over there that also comes out as a net of 0. So what you might want to try to do is to say, okay, in this particular case, car was number 1. Let's change our datum to walking, and let's kind of rerun this comparison and see how things shake out. Instead of using car as the datum, using walking as a datum. And what you try to do then is, after one run, again, you change the datum from the best one and you rerun it, and you try to find out, does that ideal solution still persist? Is it still the best one? If there is no clear best solution, or again, if there are a couple of them that are really close, maybe you can combine or merge a couple of those. If one of the solutions is clearly head and shoulders above everything else, perhaps you try to rerun those with some of the strengths removed. So what you do is you go back into car and you say, like, yeah, car just kind of blew everything away. So let's take out travel time just for now and see how things shake out if we take out that one that really was weighted in such a way that it just blew everything else away. So again, there's lots of different creative ways that you can do this. But again, the notion is not necessarily to pick the winner. It is to pick the best, the optimal, to pick the one that is going to best fit the weighted design specifications. But you should also use it as a way to combine ideas, to spur creativity, innovation, conversation, and that in the end can lead you to a better solution. So let me just wrap this up by saying that my second question for this particular assessment is for you to identify, you've identified some alternative design approaches. I'd also like to have you determine what are the 5 most critical criteria as you begin to select from among your design alternatives. I'm guessing for a lot of you, cost is going to be a big one. You also are going to need to look at things like feasibility. Is this something that I can get accomplished in the course of a semester when we get into the fall semester? So I don't want to give away all the answers, but you're going to want to identify 5 critical criteria. And then let's say you've got 5. Assuming you've got 5, how would you allocate your weighting across those 5 alternatives? Okay. So normally you would, if they were equally weighted, it would be 4, 4, 4, and 4 times 5 is going to be 20. So you're probably not going to weight them all exactly equally. Think about your weighting. Again, specify those on your question number 2, the criteria plus the weighting, and that will fulfill that requirement. So to finalize this, some really key points. First of all, as I've talked about over and over and over again, the true value is not what gets the best score. The value is the process that you go through to determine what those optimal characteristics are. The deep analysis and moving towards a decision requires this thorough understanding of the problem, the criteria, and the data associated with your potential solutions. It also requires teamwork, mutual understanding, lots of conversation, lots of communication, and that's ultimately what leads to the perfect design. Okay, that's overstating it a little bit, but that is what leads to a more optimal design that involves all people's thinking, all considerations, and the creativity that you guys all have. So with that, I will stop my recording. I do appreciate you listening to this. Make sure you hit submit before the due date for those 2 questions, and I will see you soon.